Hi class, I'm gonna discuss section 1.3 regression. Uh, we already learned how to write the equation of a straight line uh, given uh, coordinates of 1 point and a slope, or given 2 points. We can write the equation of line. Anyway, we learned to write the equation of line, we have to have slope and coordinates of 1 point. Right? Once we have those information, we can write the equation of line using point slope form of the equation y minus y1 equals m x minus x1. We learned this stuff. I'm just reminding you guys. Um, in case uh, we do not have uh, slope directly, uh, we have to have slope indirectly somehow. For instance, if they give us 2 points, like in the second case, um, we can find slope using the slope formula first, and then use that slope m in the point slope form of the equation, uh, and find the equation of line. Use the slope first and substitute that in point slope formula with one coordinates of 1 point and find the equation of line. Okay. Uh, Today, what we're going to learn is uh, again an equation of line, but this time these points are scattered, means they not stay on one straight line, right? The reason is most of the practical uh, set of data, for instance, maybe data from an experiment, those who doing physics, chemistry, engineering, or any science, um, sciences, they know, or if you're doing a survey, those data points never stay on one straight line. Uh, it is very rare if all those data points lie on one straight line. It will very rarely or never stay on one straight line. I get an example here. You see this uh, dotted line here. There you see these points. Let me move this screen up. You see these points. See, these points are scattered. This is an example for scattered data set. Now, uh, we want to write the equation of best fitted line. That means if you just look at these data points, you see it has a linear trend. It looks y increasing linearly as x is increasing. Right? It it seems it fits to a straight line, um, but not all points on one straight line. Right? So we have to write. Uh, we have to find a line that is well balanced with um, these scattered data points and write the equation of that. Right? Okay. Uh, Now, see, these are the scattered data points. I'm going to show you. See, x1, y1, x2, y2. These points are scattered data points. See, um, one or two of them stay on the line, and other points away from the line. Uh, what we want to find here is find the equation of this line. This is the best fitted line, best fitted line. or the trend line. We want to find the equation of this line. Equation of this line. That's our goal. Now, um, fortunately, uh, here we have a formula. All we have to do is use that formula. I'm gonna move this. Okay. Um, I'm gonna show you the formula now. Um, but don't upset, that formula looks hard, right? Uh, Regression line, equation. Okay. Um, Now I show you the equation of the regression line formula. So, okay, let me get the pen. Okay, this one. I'm highlighting. It doesn't look hard, but the thing is, it's coefficient A and B. We can write the uh, regression line equation as y equals ax plus b, where it's A is this. That looks strange to you, I know. Uh, and B, B is this. Once you find A, finding B is simple. All you have to do is substitute um, A here, x bar here, y bar. I'm going to tell you how to find it. Right? Now, to write this equation, I find the easiest way to learn this is using an example. Right? Therefore, for this, let's use this example one. Okay. Um, Again, you may wonder where these equations came from. It is already derived using calculus. Uh, all we have to do is use it. So learn how to use this equation. Okay. Now, uh, to find the regression equation, it is clear that we have to find this A and B. That's it, right? Where A is given by this formula Sx, uh, xxy bar, etc., etc., and B is given by this formula. Right? Now, to find A, we have to find this xxy bar, x bar, y bar, sxx bar, x bar square. I didn't discuss that yet. I'm going to discuss it right now. Right? Uh, Now we're going to find these parameters one by one. I'm gonna move this before that. I'm gonna erase this thing. Okay, I told you I'm gonna use this example to illustrate how to find this equation of the trend line or the best fitted line. Okay, example is this. We have set of x coordinates on the top line here, this here, and corresponding y coordinates here, right, in the second line. So x coordinate on the first line, y coordinate is on the second line. Um, we use these coordinates to find these parameters uh, in A and B, to find these parameters. this. Okay. Let's see how to find it. X bar. Whenever you see bar, that means the average. It is given by sigma x. Sigma means the sum. You know that. Okay. Sum of x coordinates divided by number of points. Now here, how many data points we have? 1 up to 6. We have 6 data points. So n is 6. Sigma x means, I told you, it is sum of x coordinates. So we add all x coordinates and divide by 6. We add all x coordinates and divide by 6. And we end up with this answer, 21 over 6. Similarly, we can find the find y bar. It's like here, that is sigma y, sum of y coordinates divided by n number of points. Okay. Now we end up getting uh, getting y bar this number. Right? I did not simplify this. I'm gonna substitute in the final formula as it is. Right? Otherwise, the reason is we have to simplify many times. Without doing that, we substituting everything as it is in the formula for A, and we simplify just one time. And in the same way, we're going to find other parameters involved with A. Sx is here, means sigma x bar, sum of squares of x coordinates. Calculated that here and end up with 91. S6 bar means uh, divide S6 by number of data points, 91 divided by 6. Similarly, found Sy, sum of squares of y coordinates, and Sy bar is the average of that. Divide Sy sigma y square by number of data points, n. We end up with this answer. You may notice this Sy or Sy bar is not appear on the formula for A. While we find it, we're gonna use that uh, for another formula called correlation coefficient. I'm gonna discuss that later. Anyway, Sy and Sy bar we need for some other purpose, not for the regression line, right? Sxy uh, is the sum of the product of x and y coordinates. We get this number. Sxy bar is the average of that, divide sxy by number of data points. We get this here. Okay. Now we set to calculate these coefficients for regression line A and B. All we have to do is substitute those uh, those values in the formula for A. This is formula for A. We substitute these numbers for the parameters we found, and I end up with this value 1249.11, which is nearly equal to 1249. And y, and to find d, which is equal to y bar minus ax bar, we use this a value here. I use the non-approximated a value and substituted it here for a. X bar, v bar, we already calculated, substitute them here, and I end up with this answer, 142.3, which is nearly equal to 22,142. Right? Then once we found A and B, we can simply substitute them in y equals ax plus b, and we get the equation of the regression line, which is this. Right? So that's how we find the equation of the regression line. Now, uh, even if you're using the calculator, when you're calculating these numbers, these parameters, sx, y, x bar, y bar, you see it involves uh, a lot of numbers, especially when you having big numbers and squaring them, getting the average, you may make numerous mistakes. Therefore, we're going to learn how to use the calculator for this purpose. Uh, Means if we have a way to uh, feed coordinates of points and simply get the equation of the regression line or regression uh, line coefficients, it might be easy and accurate. Right? Um, Before I uh, show you that, let me show you something else. Okay, I'm gonna erase these lines. Means I told you this regression line is for a scattered set of data points, which is like, let me show you. Okay, it's like this. And so regression line may be something like this. Okay, the thing is, how do we know given data set follows a linear regression like this? We just saw coordinates. How do we, my question is, how do we know, let me erase this set here, and how do we know if the given data set is like this? If it is something like this, now look, you cannot draw a trend line. Means it doesn't look like it is increasing or it's decreasing. It looks like something like this, the trend. Uh, anyway, it is not linear. Right? These curves, it is that we're not going to discuss in this lesson. Uh, so the point is, if the given set of data points is like this, uh, just looking at data points, we don't know if it follows a linear trend or not. Right? For that, now if you simply substitute these uh, coordinates to the coefficients a and b, the calculator gives us equation, right? Just because calculator gives us an equation, we cannot believe those data points follow a linear trend. Okay. This is how we confirm them. There is a thing called correlation coefficient. I'm gonna paste this and move on. There is a thing called correlation coefficient. We calculate that using same parameters we calculated already. Um, the thing is, if this correlation coefficient R is uh, -1 or 1, that means all points are on one straight line. That's the perfect linear correlation. If if R is close to -1 or 1, then we can say, okay, given set of data points, they follow a linear trend because it is close to -1 or 1. But if R is close to 0, if it is equal to 0, no argument, data not following uh, any linear relationship, right? Still, if R is close to 0, still we can say, okay, given data set, not follow a linear regression. Okay, understood? Uh, I, I repeat it. If R is close to -1 or 1, -1 or +1, that means given data set follow a linear regression. Maybe it is increasing or decreasing. Anyway, it is linear. But if R is close to 0, given data set does not follow a linear regression. Okay, now in the same way, this equation for regression, this equation for correlation coefficient, this formula is found using calculus. Right? When you learn higher calculus, you will learn how to derive this. But at this level, you're not going to learn how to derive this. You just going to use this formula. Right? Um, you see this SY bar here. We calculated that before. In fact, we calculated everything. I told you when we calculate A for the regression line, this SY we did not use there. Right? I told you we need that later on. This is where we using it, SY. Okay, now we have all these parameters calculated before. Uh, So what we have to do is substitute them and calculate the value of R. Let's do that as example 2. Okay. Uh, Example 2 is find the correlation coefficient for example 1. Um, the procedure is simple, means we have the formula. This one, all you have to do is substitute these parameters that we calculated before. Right? Uh, Once we substitute them. I substituted them in this line, and I end up with this answer for R, 0.999207, which is nearly equal to 1. Since R is nearly equal to 1, we can say uh, the given data set follows a linear regression, or uh, uh, there is a linear correlation between X and Y. Okay, now uh, okay, let's see how to do this using calculator now. I'm gonna erase this. Okay, um, or we can find coefficients of the regression line and this R correlation coefficient as well using the calculator. Okay, let's see how to do that. Um, I'm using, uh, I'm going to show you that using TI-89 calculator. I'm going to turn on this calculator first, turn it on, and first of all, we want to feed this set of data from example one. Okay, before we enter that, we have to uh, press the mode key to find uh, which mode this graph is in. Graph should be in function mode. If press the mode key on your calculator, check if the graph is in function mode. If not, um, press the right arrow key. It will show you options there. We can use up and down arrow keys to move this uh, highlighted one and select the function and click enter, or simply you see function is under number one, we can press number one or enter key, same thing, right? So I click enter. All right, that's it for the mode. Um, then go to applications, apps, press apps key and select data matrix editor, number 6. You may move this highlighted window to 6. I'm going to press number 6 directly. Then it asks if you want to use the one already in calculator, or create open one, or uh, create a new one. We're going to create a new one. So I press 3. Okay. The type should be data. If not, again, use the arrow key and do it. Folder should be main. Don't change that to anything else. Variable. Variable means the name of the file that you're going to create. We can give any name. Um, I give it a name XX, double X, right? I give it the name XX. That's all. You don't have to fill anything else there. Click enter. Click enter again. Now, this is the place where we enter X and Y coordinates. Let's enter x coordinates under C1 and y coordinates under C2. And we can change these C1 and C2 labels. We can change these labels C1, C2, C3. We're not going to use C3, C4. We have more labels here, and we have uh, more rows down here, more columns to the right and more rows down. But we're going to use only C1 and C2. So C1, let's enter X coordinate, assuming column 1. This is column 2. Why I asked you not to change this, because we're going to use this later on. If you change this, you have to remember that what you changed to. So it's easy to not change them. Okay, I'm going to enter X coordinates here, 1, 2, up to 6. Now I'm going to enter Y coordinates, 23,433. Enter second one. Okay, I entered all data. Okay, just check if we enter right points, right numbers. Um, okay, then after you verify the set of data, press F5, calculate. Yeah, calculation type, change this to variable to uh, linear regression. Say line reg on number 5. See on number 6, ln reg, that is different. Press number 5 or move the highlighted window to 5, line reg. I press number 5. Then X and Y. You remember we enter X in C1. That's why I asked you not to change that. Otherwise, if you change that, you have to enter the name that you changed. Since I did not change that, I enter C1 and C2 here. First time calculator is locked for uh, letters, so I simply press C, and then I have to off this letter mode by pressing alpha and then 1. Then for Y, I have to enter C2. For C2, I click alpha, this parenthesis C on top of that, you have C, C, then number 2. Okay, then it does store regression equation. Yes, we want to store the regression equation. We have to give it a name. So we have this whole bunch of y1s, y1, y2, y3. So simply let's select y1 Uh, well, now you don't have to change anything else. We enter. Once you enter, calculator gives us these coefficients for the regression line, A, B, and correlation coefficient. Uh, also, it's giving us correlation coefficient square, which is R square. Uh, you don't need that, but just understand this R square is the square of CORR value. Um, this number on third row, if you square this, you get the number in the fourth row, but you don't need it. Um, you see, uh, we get we get almost these numbers, almost all these numbers, and correlation coefficient again close to uh, 1. Therefore, we can say um, this given data set follows a linear regression. Right? Okay, that's it about finding the regression equation. Substitute this A and B. The equation is y equals ax plus b. Right? Uh, okay. Um, let's see what else. Okay, we would like to plot this data set. For that, okay, let's get out of here, pressing enter key. Now, you may click F5 to make sure um, if everything is in the order, everything is fine. See, this is line reg C1, C2, uh, Y1X is there. Right, once you make that, it is in the order. Then to uh, plot these data points, press F2. To display plot setup screen, F2, F2 is here. Then to uh, define the plot 1, press F1. Okay. Plot is a scatter plot. Um, mark means be using boxes for mark. You can change that, but don't change scatter. Leave this scatter. Uh, uh, but box, if you want, you can change it to different one, maybe a dot or square, plus sign, whatever it is. But I leave um, it as it is. So I use boxes. Uh, everything else the same. X is C1, Y is C2. Okay, press enter. Uh, once you hit enter, it's saved here. Now to display the Y editor, press the diamond key. Diamond key is here and F1. Press diamond key and F1. Um, what we want to plot 1, select plot 1. And if it is anything else, move your highlighted window to plot 1. And then press on zoom F2. There we have to select zoom data. I think it is on number 9. Let's see. See, here it is. See the number 9, zoom data. You may move the window there or click on number 9. I click on number 9. Once you click that, plot those data points and it draws the um, uh, regression line also, right? So that's all about it. Right? Okay. Now you see this as a positive regression. We had a positive number for A, correlation coefficient also a positive number. Those two has the same sign. A and R, they have the same sign. If it is positive, line is increasing. If they are negative, line is decreasing. Let's see another example. I'm gonna quit this. Second escape is the quit. I quit that. Let's get another example. I'm gonna use example 2 from the book. Let's see. Let's use directly the calculator this time. I believe you have book. Uh, I read it. The table below shows the number of deaths by fall in United States over a 5-year period from 1978 through 1982. Gives us a table. Um, let's take year as x coordinate and number of deaths as y coordinate. Now you see year is 1978, 1979, 80, 81, 82. The difference is 1 unit. Therefore, same as previous example, let's use 1, 2, 3, 4, 5 for year or the x coordinate and number of deaths. And these numbers given as y coordinate. Right? So if you do a few times, means if you do few examples using calculator, you may remember this procedure. First, click mode to see if the graph is in function mode. Yes, then enter. Then use apps, applications, and use data matrix editor number 6. We're gonna create new file number 3. It is data main. We have to give a name and variable. Go to variable and give it a file name. Last time we gave it double x, xx. This time let's give it triple x, means x, 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 3 x's. All right, easy to remember, right? Click enter, enter again. Now we got this to enter our set of data. Under C1 we do x values, under C2 we do y values. 1, 2, 3, 4, 5. Okay, now go to C2 column and let's do y coordinates, means number of deaths in this under this C2. 13,690. 13,690. Enter. And the last one, 20077. Enter. Right. Just move up and down to make sure we enter correct numbers. Okay, it's good. So it is good. Let's F5 calculate F5 here. This is not touchscreen. I have to use these keys on the calculator. F5 to change calculation type to linear regression line reg, which is number 5. I click number 5, then X and Y to C1 and C2, C1 and Y to C2, C2, then store regression equation to, let's see, Y2. We selected Y1 before. Enter. Okay, that's it. Okay, so it gives us A is this, B is this, correlation coefficient is this number. Again, it is close to -1, negative 0.954 something. R square, you don't need that. There notice this A is a negative number and correlation coefficient is also a negative number. I told you A and R should have the same sign, which is true here too. Right? Anywhere A and B, I mean A and R, A and correlation coefficient, they should have the same sign. Right? Okay, once we have these coefficients, we can do the equation of the regression line y equals ax plus b, right? Y equals ax plus b. Um, uh, let's try to plot this too. Now, since a is negative, we should expect a decreasing slope. Since a is negative, it is the coefficient of x, which is the slope. We should have a decreasing line. Right? Press enter to close this window and for plot setup F2, then F1 to define the plot, scatter box. Box is fine. X is C1, Y is C2. Everything is okay. You don't have to change the other things. Enter and then let's press F2 to zoom to copy plot one. That's okay. F1, we define the plot. Okay. Okay, now that's good. Then go to the Y editor. Okay, Y editor, and then let's zoom this F2 and zoom data, which is 9. Zoom data, hit on 9, and we get these points. See the data points, and it does the regression line. You see clearly, and it is a decreasing line. We saw A is negative, therefore we expect this. It is a decreasing correlation between X and Y, right? Okay, that's all I have for section 1.3. Let's close this window. Uh, let's go back to the lecture document. Okay, okay, that's all for section 1.3. Thank you for participating. Right? Take care, guys.